All right, so let's see if we can get some notation here. So for a second derivative, we're going to have an f and then a double prime, so two little marks. All right, that's going to indicate a second derivative. And then if we have a third derivative, all right, we're going to go three little marks. Okay, so the notation is easy to get a hold of. You do have to kind of pay attention to those number of little marks, especially if they put this in the question and it says find the third derivative, but it uses the notation. You just got to count those little things. Now, after 3, and we usually don't do the marks anymore because then it just gets too many marks in there. And so for a fourth derivative, all right, it's not uncommon for you to see an f and then a 4 in parentheses. Okay, so that could be a fourth derivative, a fifth derivative, a second derivative. So just to avoid the little hash marks. Okay, so that's pretty much the common notation that we're going to use for our high order derivatives. I also want to, at this time, take a kind of a look at everything that we can do with our first derivative and our second derivative. All right, we will add to this list as we go on because we're going to learn different types of problems and how to apply this stuff. All right, but right now for our first derivative, things that we know about our first derivative, I should say. All right, we know that what? When we take the derivative of a function, then ultimately that's going to give us what? It's going to give us the slope. All right, we can use it to find the slope. If we take the derivative of a function and it's like a 2x, then we know that that's the slope at any point along the curve. And if I want it at a specific point at x equals 2, I can plug in 2, and then I know the slope at that exact point. All right, so right now we do that. We use it to write the tangent line. So if I ask you to write the tangent line, which that's been a pretty common question that we have done up to this point, you have to find the derivative. All right, and then follow the rest of the steps out that way. And then, since we've done our acceleration, velocity, and position function, we now know that we can use our first derivative. If we take the first derivative of that position function, then we can use it to find the velocity. So right now, that first derivative is pretty important. It does like 3 things for us right now. Okay, and like I said, we will just continue to add to what that first derivative can do. All right, now new, we haven't really done a whole lot of second derivatives, but we can start a little list. For our second derivative, right now the only thing that we have done is, okay, if we had that position function and we took a second derivative, that would get us all the way down to our acceleration. All right, so we know that we can find acceleration. All right, and then coming up here, we haven't done it, but we're going to talk about it here pretty soon, actually. We're going to learn that it will find the concavity. All right, so we have increasing, decreasing, we've got maxes and mins. We've talked about all that from pre-calc. All right, and concavity is, we'll talk about something concave up, concave down. All right, when the curve goes up and it has a maximum, all right, then there's an area that's underneath there, right? So that'll be concave down. If we have a minimum, like an upright parabola, all right, you've kind of got some, you could fill that parabola in with water, that's going to be concave up. All right, an area where it's depressed that we could put something in. Okay, so for right now, just a little summary. We're going to keep track of this, all right, because the farther we go into this, then these two things are going to be very important. You're going to have to know, okay, do I need a first derivative? Do I need a second derivative? What do I need to find the answer to the question? All right, so let's do a couple of these. All right, we'll start out with our polynomial curves because they're pretty straightforward. Okay, so let's just say we had a y equals a 4x to the third plus a 2x squared minus an 8. All right, this is just going to be a straightforward one, not hard. We're not going to do anything fancy with this one. I could ask you to find first derivative, second derivative, third derivative. We could just keep going, keep going, keep going. All right, so if I ask you to find first derivative, all right, double prime notation on the y, just like a single prime. Oh, I don't want to go first. Let's go first derivative first. All right, notation is going to look the same. All right, so good old-fashioned power rule. Don't let me screw up. All right, 12x squared plus 4x, and then the 8 goes away, right? So that's our first derivative. All right, let's do a second derivative. Now there's the double prime. All right, power rule again. So 24x plus 4. That's a second derivative. Okay, could I do it again? So third derivative, 1, 2, 3. That's going to be 24. Okay. Could I do it again? Yeah. This will be a fourth derivative, and it'd be 0. And so the directions are just going to say, find the second derivative, find the third derivative. And you just got to do it over and over and over. So that's just straight power rule. That one's not hard. All right, now, what's going to be extremely important is the quotient rule. Remember when we did that last week? All right, you have to be able, chapter 3 is going to be curve sketching. All right, and we're going to use the first derivative and the second derivative. And almost every time on the curve sketching, I mean, we'll do all the different types of curves, but a lot of times we're going to do rational curves. They're going to have vertical asymptotes. All right, I mean, we know what rational functions look like. We've done swoopies and opposite sides, swoopies at the top. They get more complicated than that. All right, so if it's a rational function, you've got to be able to do that quotient rule successfully, and you got to be able to do it twice. All right, so let's take a look at a quotient rule. All right, so let's say let's go back to our f of x notation, and let's say our original function is an x plus a 2 over an x minus a 1. All right, and we'll just start with nice little baby functions right now. All right, if I want a second derivative, all right, I have to do the first derivative first, so f prime of x. All right, now this is quotient rule. We're still doing ddx notation, right, because we've really only done one assignment on this, right? So we need the bottom, which is x minus 1. Let's go ahead and use that ddx notation. So ddx then of the top, which is an x plus a 2, minus the top, which is an x plus a 2, and then times the ddx of the bottom, the derivative of that bottom, and then all over the bottom squared. All right, and now like I said, I'm still using that ddx notation. Eventually you guys will drop that. Okay. All right, now on this next line we can actually take the derivative here, so we'll have an x minus 1. Derivative of x plus 2 is just a 1, so that's not hard. I don't even need to do anything there. All right, x plus 2. And then derivative of x minus 1, again, it's just a 1, so I don't need to do anything. All over x minus 1 to the second power. All right, but you see how this set of parentheses here is important? All right, minus everything to the right, which means I got to go through and change the sign. That's a common place where people miss this. All right, so let's go x minus 1. I'm going to remove that set of parentheses, and then minus x minus 2 all over x minus 1 to the second power. All right, let's see what x minus x crosses out, so I get a negative 3 on top. So a negative 3 over x minus 1 to the second power. So there's my first derivative. All right, I'm going to rewrite my notation here. All right, that's my first derivative. All right, now let's say we're doing a second derivative. If I'm going to now need to calculate a second derivative, I'm going to start with that first derivative. I'll have a negative 3 over an x minus 1 squared. All right, do you think we can leave out the ddx notation on this? Because what's that top going to do? Every time I take a derivative of that top, I'm going to get a 0, right? And what's actually going to happen in this is technically we're going to have chain rule in here, and we don't know chain rule yet. But because of the way this particular problem is set up, it's just going to be a chain of multiplying by 1. You won't even know it's happening. All right, we'll do chain rule here in like a few days here. All right, so I want second derivative. All right, so I need the bottom, x minus 1 to the second power, times the derivative of the top. Derivative of that constant is 0, so I'm just going to go times 0. I left out the ddx notations, okay? Minus the top times the derivative of the bottom. All right, so like I said, right now you don't know chain rule, but is this something raised to the second power? Do we know power rule? Can I pull that 2 down in front? Can I pull the 2 down in front and go x minus 1 and then subtract 1 from the exponent? All right, and then there would be a times 1 for a chain, which you don't know yet, but at times 1 it won't make any difference. Okay, and then all over an x minus 1 to the second power raised to the second power. Alright, now I might suggest those brackets around there because we don't know what the heck we're going to get into. Alright, now this right here, that all just goes to 0, right? Alright, this is be negative 6 right here. Alright, but let's show this minus right here. Let's go ahead and put our square brackets in, negative 6, and then times that x minus 1. All over, what's the bottom? It's going to be an x minus 1 to the, what power? Fourth, because we've got power raised to a power, so that'll be to the fourth. Okay. Now, I don't know how much I want to distribute and how much I don't. Let's go ahead and do some distributing property. Alright, so let's keep the negative on the outside. Negative 6x plus 6. Good so far? Can we distribute one more time? So it would be positive 6x minus 6, don't let me screw this up, all over x minus 1 to the 4th. I wanted to do that, get down to a nice little thing here. Okay, now can I factor out 6? And why would I want to factor out the 6? If I factor out 6, am I going to have an x minus 1 in the top? And then I'm going to have an x minus 1 in the bottom. Alright, so let's go ahead and factor out the 6. X minus 1. X minus 1 to the 4th. I've got a binomial of x minus 1 to the 4th. I've got a binomial of x minus 1 to the 1st. Can I use laws of exponents on that? I'm going to have an x minus 1 raised to what power, and where's it going to be? Laws of exponents. When dividing like bases, subtract. Okay, so we subtracted and put it where the highest one was. So I'm going to have an x minus 1 to the 3rd power in the bottom. Right, so we'll have, I'm running out of room on my paper, 6 on top, and x minus 1 to the 3rd. Now, could you probably have crossed out up here a little bit sooner? Yeah, but I wanted to make sure the algebra steps were clear. Because you saw that x minus 1 up there at the top. But I just wanted to make sure that we didn't drop any negatives. So this is a, let's label it second derivative.